In this video, I'll be going over the Week 4 lab, and within the Week 4 lab overview is where you can download the lab document that you'll need to fill out and answer all the questions, and then you can see a breakdown of how much each question is worth towards the total. And here is the Open Lab worksheet, and you can see we start off by needing to set up our Excel worksheet. So let me jump into Excel and show you how to do these steps. The directions here are pretty spot on, so just try to follow them step by step. We start off in row A, we're just creating labels for our number of successes. And so we're going to be doing a binomial experiment here, and the number of trials are going to be 10. So the possible number of successes we could have are either 0 successes all the way up through 10 successes. And we're going to start off by looking at a binomial situation where the probability of success is 1/4. And we're going to do the formulas here in Excel to see what is the probability of each of these different numbers of successes when the probability of success is 1/4. And here's the formula you'll need to use. It's spelled out here in the directions. Binomial distribution, and then the first argument is the number of successes. We're calculating the probability of getting that number of successes. So in this case, A2 is 0 successes. And then the next argument after your comma is how many total trials there are. So 0 successes out of 10 trials when the probability of each success is 1/4, or as a decimal 0.25. And then you want to enter false for the final argument. False gives you the probability of exactly this number of successes, whatever you enter here, in this case 0. If you wrote true here, it'd be the probability of that number or anything less than it. So for 0, that wouldn't, there's nothing less than 0, but if you typed in like a true down here, and let me just show you that. So first, let's drag and drop this down. This is the probability of it getting exactly 0 successes out of 10, exactly 1 success out of 10, and so on, when the probability of success is 1/4. So like I was going to demonstrate what the true argument does. If you type in true at the end, it's the probability of getting that number of successes, in this case 3, or anything less than it. So either 3, 2, 1, or 0 successes out of the 10 trials. And you can see the result comes out to around 77%. And you can get that straight away with the formula by using true. And you can also get it by adding up the probabilities here of those individual results. So either way, you're getting the probability of getting exactly 3, 2, 1, or 0 successes. So in this lab, in this setup here, we don't want to use true, but I wanted to demonstrate the difference between what true and false is doing in the formula. So you will then repeat these steps, and I'm not going to do them all in the video because the answers will be exactly the same when you do them. But you want to do it for 1/4 we just did, but you also want to do it for 1/2 and then 3/4. So you'll have 2 more columns looking somewhat similar to what I did here in the video. One thing I want to point out before moving on is that numbers written like this are actually in scientific notation. So this E and then -5 means we would actually multiply this 2.86 times 10 to the -5th power. Or a simpler way of thinking about that, it means we need to move the decimal 5 spots to the left. And in this one, it would be 7 spots to the left. So these are actually very, very small numbers. So you can manually move the decimal 5 spots to the left and see how small it is. You can also change it to a number instead of general, because in general, Excel uses scientific notation for really small numbers. And it looks like it's 0.0, but it's just because the number is so small. If we add more decimals here, we see just how small the probability is of getting 9 successes out of our 10 trials. After you've created the binomial distributions, for the 3 different probabilities, 1/4, 1/2, and 3/4. Then we want to create scatter plots, and we're going to insert them here in the document. Just to show how to do that, for 1/4, you would select the data, and as it outlines here, we want to insert the scatter plot. And Excel then will draw that scatter plot for you with the number of successes on the x-axis, and the probability of each of those different outcomes is shown by the height of the dot on the y-axis. And you can change your title to make it more descriptive of what this scatter plot's showing. One thing I wanted to point out is that when you're going to graph your second and third scatter plots, I wanted to show how to properly select the data in case you're having trouble with that. So I created a column here with a binomial distribution that has a 90% chance of success. And if I wanted to select just that column, I'll select successes, then hold Control down to keep that selected, and I can skip over to the exact column I want and select that as well. And so now I've let go of Control. I have my 2 columns selected that I want. And when I draw, insert my scatter plot, it just draws off of those 2 columns. So looking at number 2 now, we're going to refer back to the database we used, the same one we used in the week 2 lab. And one of those columns was about a coin flip. And so flipping a coin, it's a binomial experiment. There are only 2 outcomes, either heads or tails. The probability is fixed each time at 50% success. And the outcomes here were the number of times the students got tails when they flipped the coin 10 times. So they could have got any number from 0 all the way up to 10 when they flipped the coin. And these are the results that they got when these students flipped the coin 10 times. So for number 2, you'll want to find the mean and the standard deviation of those results that they got. You can use Excel to do that, the equals average, and then select all that data of the coin flips. That'll give you the mean. And then that formula equals standard deviation dot s, because we have a sample here. And then again, select the data. That gives you the standard deviation of those students' coin flips. And so moving on now through the rest of the lab here, we're actually going to be referring back to questions 1 and 2 and doing a little bit of comparison and contrasting between the results. So what we just did in part 2 was look at some actual data that was gathered around the binomial experiment with 50% probability. And we're going to kind of compare that and contrast it to question 1, where we had the theoretical probabilities for a binomial experiment that has a 50% chance of success. For question 3, what you want to do is look back at what you did in Excel at the very beginning and use those answers to fill in the table here. And you'll want to do it for your column that had 1/2 as the probability, because that is the probability of getting a tails, which we'll call success, getting a tails each time you flip a coin. So for example, if I was doing it for 1/4, I would put this value in for the probability of getting 0 successes, and this value for the probability of getting 1 success, and so on. So do that for your column with 1/2 success. For number 4, you're going to use the probabilities that are listed up here in number 3 to answer these questions. So for example, the first one, the probability of getting the number of successes to be greater than or equal to 1, you would add up all the probabilities greater than or equal to 1. So pay attention on each of these, whether it's greater than or equal to or just greater than. So for example, the second one here, strictly greater than 1, you would start by adding up the number of successes 2 or more, and all of the numbers then that are greater than 1. So the easiest way to calculate these is probably to jump back in Excel and just make sure you're summing the correct values. So anything strictly greater than 1, I would just grab the results for 2 through 10 outcomes, and sum up those probabilities to get the probability of getting a result where my number of successes is some value greater than 1. So pay close attention to all these and just make sure you're reading the sign correctly, whether it's strictly less than or if it's less than or equal to, the same for greater than. And just make sure you're summing up the correct probabilities for each of these questions. And for an OR probability, recall that you want to include the probability of falling into either one of the buckets. So calculate the probabilities for each of these and then add them together to get the total probability for the OR statement. Number 5 gives you the formulas that you need for mean and for standard deviation. So use those formulas and our values for NP and Q that are stated here and calculate the mean and the standard deviation. So be sure to either show your work or explain how your answer was calculated to get full credit. Recall that P is the probability of success and Q is 1 minus that, which would be the probability of failure. For number 6, answer this question completely. Use the definition of what a binomial experiment is. You can find that in your textbook. And we're just talking about why this coin flipping scenario fits the necessary criteria to be a binomial situation. And then in number 7, we're going to be comparing and contrasting the mean and the standard deviation from our 2 different scenarios here. The first scenario in question 2, where you have the actual data from people actually flipping a coin, a real life outcome from a binomial situation where there's a 50% chance of success. And we're comparing that to question 5, where we had our theoretical mean and our theoretical standard deviation for a binomial experiment where the probability of success is 50%. So compare those values and explain how they're related in a short paragraph with several complete sentences. If you have any questions about any part of this lab, please reach out. I'll be happy to assist. And I want to wrap up the video by pointing out in the classroom some pre-programmed Excel calculators that you can access through the Files tab. You won't necessarily need these for the lab, but these will be very, very useful as you work through the homework assignment. And so there's a binomial distribution calculator, and if you scroll down, there's also a Poisson distribution calculator as well. So I encourage everyone to download both of those. I think you will find them quite useful.